Thank you. All right, everyone can hear me? Sound is good? All right, hi, my name is Sid. I lead data at SDF. This is a really exciting time to be a part of the Stellar Network. We finally got Protocol 23 launched on mainnet. Woo, Tomer's super thrilled about that. Yeah, can I get applause? Okay, but it's also really exciting because we're attracting a lot of new builders, and even our Meridian theme is pointing to the fact that we're really growing up and maturing as a network. And why I'm excited about that is because part of the growing up and maturing process is becoming interested in analytics. So you have a plan of where you want to go, you want to get there, and you want to make informed bets on how to get there. And you're going to do that by seeing what your users are doing, how they're adopting your tool. Now, I think analytics gets a bad rap for being expensive. And the reason why it gets this bad rap is because Snowflake and BigQuery are legitimately expensive. They're pay-to-play tools. But analytics doesn't have to be expensive. So I'd like to take you on a road trip with me. It's going to be kind of cheesy. And we're going to have a shoestring budget. So consider the next 15 minutes your road trip guide to budget-friendly analytics. Now, if you are new to the Stellar Network, I do want to shamelessly plug that we host a public open analytics data set. We call it Hubble. You may have heard of Horizon or RPC. If you're going to come and yell at me about retention windows in Horizon and RPC, I want you to use Hubble. Go query our BigQuery data to find that old data that you care about. When we set out to build Hubble, we kind of saw it as us building like new infrastructure. We wanted to pave a new road in the ecosystem. So when we started before this, we didn't have a lot of insights on the network. SDF itself was actually running custom scripts on a Horizon node to compile quarterly report metrics. This was really terrifying, in my opinion. And our end goal at the time was that we wanted to build a public, easy-to-use analytics data set. So our goal was that you would be able to ask what you wanted when you wanted. Now, what we didn't realize when we built Hubble was that we had actually built a toll road. So we've actually gotten a lot of feedback from you guys that you're burning through credits really quickly. You don't like that you have to use BigQuery. And so what I want you to take away from this talk is that, so some people would take the scenic route in this process. They would detour around this really nice toll road that we had built out. People were paginating over Horizon, trying to rebuild historical state of a given point in time, or they're burning through RPC credits really quickly. What's problematic about doing something like this is that the data doesn't reconcile easily and the results aren't reproducible. So it's really hard for you to share your code with me and me get the same result as you. So what I want you to take away is that Hubble is not the only way to your destination. You have options in analytics, and if you don't like Hubble as your option, I want you to pick a route that works for you. So we're going to go through 3 of those options today, and depending on what you're doing, one of these might make sense for you. And the way that we're going to go on this journey is we're going to ask the same question 3 separate times. Since we're in Brazil, I thought it would be fun for us to answer a question about Tesouro, which is Etherfuse's Brazilian real stable bond. And so we're going to figure out what the total circulating supply of Tesouro was at a given point in time. The first way we're going to do this is we're still going to use a tollway, but it's going to be a less expensive tollway. So if you just want to pay a toll to save time and get there, I recommend you check out Dune. They have both free and cheap query options available to you. So the analyst query plan starts at around $45 a month. What's cool about it is they have that free tier where most of the queries that you're going to want to write on the about the network can run on that option. You can always size up into a warehouse if you're running out of, if you need to run something for longer than 2 minutes. It also has this really nice marketplace of both enterprise-curated content as well as community-driven content. And you can view any of those dashboards without using credits. So you can really take advantage of other people's work on Dune for free. So let's open up Dune. And we're going to answer this question of what was the total supply of Tesouro as of July 15. Now, when you use Dune, it's going to have a very similar look and feel to other modern data platforms. There's a data catalog built right in where you can browse Stellar tables, look at the schema that's here. I've pre-written a query that's going to calculate the circulating supply. How you do that is you calculate the inflows and outflows of the source asset issuer. My favorite way to grab asset issuers is just to go into Stellar Expert, search for the asset, and you can grab the G address right out of the URL there. So we're going to pre-populate my query with the G address that we need. My caveat to you is if you do this, make sure you're not grabbing a scammy asset or a spammy asset and that it's the real thing. For the sake of demo, I'm actually going to size up to a large warehouse and pay for this query using credits. The reason why I'm doing this is on the free tier, this runs in about 45 seconds. I don't really want to wait here 45 seconds for that to run, but this is running right now. And it's going to calculate circulating supply for Tesouro, which is about 1.35 million reais. Now, you can cross-reference this against Stellar Expert. They also keep circulating supply there, but you can't actually fetch that data from there. It's just baked into the UI. So we found the answer. It's 1.35 million reais. But that's not the only route that we could take. We could also take what I'm calling a back road. And the reason why I call this a back road is on a map, it's going to look like a shortcut. But just because it looks like a shortcut doesn't mean that it is a shortcut. It's going to be a little bit messy, it's a little bit hacky, and it can be questionable at times. So do at your own risk. But you can actually export data from our BigQuery data set, download it to a platform of your choice or locally, and then load it into a database. So for the next two examples, I'm going to use DuckDB. This is kind of a newcomer in the analytics ecosystem. People are very excited about it because it's basically like the SQLite of analytics. So instead of you having to load a database, you can bring a query engine to wherever your data is and run it super quickly. I'm going to actually make this even hackier than me exporting data from Hubble. And I'm going to keep the data in BigQuery, load a Duck database from a Jupyter notebook. So all I'm paying for is the storage costs in GCS. I see Tomer's making a look at me. But doing this is going to be about $4, which is pretty cool because I'm going to load the entire token transfers table in there, which is 3 terabytes. So what you can do is if you open up BigQuery, you'll notice that the schema looks exactly the same as Dune. But from here, with Protocol 23, we have created a brand new data abstraction that we're calling token transfers. You'll see this on other chains as well. If you want a hyper-simplified view of sender, receiver, asset information, and nothing else, you can use this table. It's very easy to query. And what we're going to do is we're going to write a very simple SQL statement to just export the data that we want out of this token transfers table, and we're going to keep it in GCS. So I'm going to export these as Parquet files. They're going to be in a bucket that I'm going to call Shoestring Analytics. And BigQuery is smart enough to partition these as it sees fit so that your data is going to load easily into a DuckDB. So I'm going to open up a Jupyter Notebook in Google Colab. I'm going to install DuckDB, and then I'm going to load a token transfers table inside my Jupyter Notebook. So by running this, I've created a table. You'll see that the schema looks exactly the same as our token transfers schema within BigQuery. So those Parquet files, you can introspect and build the schema on the fly. And this is about 11 gigs that I now have in memory in my Jupyter Notebook. Here, I'm just going to sum the mints, subtract the burn and clawback events to find my answer, which again is 1.35 million reais. The last option is my favorite option personally, and I'm calling this the open road. So with open roads, they're not always going to be the quickest route, but this is really what's going to give you freedom and control to build what you want, how you want. When we set out to build Hubble, we were really wanting you to be able to ask the questions you want and get the insights you want. But what we heard from the community is you don't just want to ask those questions, you also want to be able to build these analytics yourself. So what we've been focused on in the last year at SDF is making sure that we have those building blocks in place so that you too can build data pipelines. We recently released, in partnership with GoldSky, a free public data lake. So think of the history archives, but for TX meta. This means that you can rewind to any point at the blockchain and build state for that point in time. We also realized we made a silly mistake and didn't have Parquet file support for our Stellar ETL framework. So we now have Parquet file support for loading those files somewhere. And we're getting a little bit smarter and better at our data abstractions to make sure that you guys have better data curation when you want it. So that's what that token transfer schema was. We're also working on a balances one right now that should be released later this year. But what you get with these building blocks is then you can stitch together your own data pipeline. So you can ingest data from that S3 bucket, which contains the raw XDR, transform it using our CLI, so you don't even have to define the transfers if you don't want to. You can just use our code. And then you can load this into a DuckDB. If you're doing this locally, it's about 30 lines of code. It's pretty easy to do. And we're going to actually do it right now. And we're going to do it on my laptop, which is 4 years old and has 50 gigs of memory left on it. So this is going to be super fun. I've got Stellar ETL installed locally. It's written in Go, so I'm going to build it. But then using our CLI, it's one command for me to export that token transfers view that I was talking about. So this export TTP, token transfers processor. And I'm going to do this for a really small ledger range. I did this before the demo as well, but we're going to export 12 ledgers right now into Parquet files. So that command just ran. The 12 ledgers are now contained within a file. And I'm going to tail this directory so that you can see those files in real time. Now, I did have to run this over the entirety of 2025 data, which took longer than the 5 seconds it's taken here. We'll talk about that in a second. But you can open up these files and see that the schema looks exactly the same as that token transfer schema we saw both in BigQuery and Jupyter Notebook. Now that we have that, I'm going to grab a DuckDB command really quick and build a table on the fly. So now I'm going to create my token transfers table on top of those Parquet files that I had just exported. And now I can go into Duck. It has its own query interface. And I should, if everything went right, I should be able to query this token transfers table. So we're going to select star from the token transfers table. Do as I say, not as I do. Running a select star is never a good idea, but I'm going to do this just so that you can look at the data itself. I'm also going to add a limit on here, which is going to make it a little better. But you'll see that the schema got truncated just because of my window size. I'm going to copy paste that same exact circulating supply query that I ran in a Jupyter Notebook. I'm going to run it locally, and I'm going to get that same exact answer of 1.35 million. Hey, ICE. So look at that. Oh, look at that. You may at this point be wondering which route is best for you. I don't know. I can't tell you that. But what I can tell you is that you have multiple options now. So if you're willing to pay a little bit of money up front and you just want answers now, I recommend that you play around with Dune and see if that's a good enough solution for you. Where Dune will bite you is that since it is a credits-based model, if you build some kind of dashboard and want that refreshed on some kind of cadence, like a daily cadence, you could sneaky burn through a lot of credits quickly. If you want more control and you have a little bit more time on your hands, you could either export data from Hubble or build your own local pipeline. The local pipeline option does require a little bit of expertise. For me to download 9 months of history, it did take me 46 hours. So you may have to do a little bit of parallelization there. But you do have full control in a totally free local stack if you do that option. So pick one of these routes, try it for yourself. I included a bit.ly link to a GitHub reference implementation repo. So all 3 of these options, we have the code, we have readmes for these if you want to walk through these examples yourself. Please do it. We also have a Discord channel called Hubble. If you run into issues with any of these, you should talk to us. Thank you. If you are a data nerd like myself, please connect with me. Find me later. Here's your free NFT.
Thank you very much. Great work. Thank you. Do you want to take questions now? I mean, we have a minute, and in the interest of using it, I mean, we have a rare opportunity here. Does anyone have a question? Any questions for Sid? Tomer. Oh, I took your mic.
Thanks. Awesome talk. Although the second route seems pretty janky, I'm not clear why anyone would do that. But that's not the question. You said that bringing all history takes a lot of time. But once you get it, is it actually feasible to populate a database locally with entire history and run queries on it?
Yeah, so it took me about 46 hours to export it locally, but then to build the table took about 11 minutes. And once the table was built, then you can query it to your heart's content. So it's very performant once you have the database loaded itself.
That's awesome.
Cool. Awesome. Thank you very much. Thanks, everybody. Thanks, Sid. Give a round of applause.